Last classes we have been doing problems of single mirror only. Okay. Now what will happen if we have two mirrors? Okay. So let's do these problems. We will know. So here I have two mirrors, concave mirror and a plane mirror here. I have a point object. Here also a point object. Here I have some object of height is given. It is 2 centimeter. It is kept at a distance of 15 centimeter from here. Okay. Here also it is 15 centimeter. Here it is 30 centimeter. Now what we have to find? In all the three cases, if you read the problems, what we have to do is we have to take first reflection from concave mirror. From this, okay. Here also first reflection concave mirror. Here also first image is considered from concave mirror. That means in all of the cases, you see, you cannot stop the light rays. They go on all the directions, okay. But we are considering the light rays going towards the concave mirror first. Okay, so the light rays are going towards the concave mirror. Okay, makes sense. Here also. So this will make some image. I will get some image from the concave mirror. Okay. Now, the light will be reflected. It will go towards the plane mirror. Okay, that will also form an image. We have to locate the second image. Locate second image. So first image from this mirror, second from this mirror. So where that image will be? Here also. Find height of second image. First image from this one. Okay, concave. Let me write it as M1. M1. This is M2. This is M1 here and M2 here. Here also, this is the first mirror M1, this is the second mirror M2. This will form some image. Now that image will become object for this mirror. Okay, we will see how that happens. Let's start with the first problem. Okay, the very first problem. Okay, it's like this. Okay, so let's look at the M1. M1, okay, 1 over V1, okay, what is M1? Okay, let me draw it here, let me draw this diagram. We have to draw the diagrams also, okay, let me draw this diagram here. This is my first mirror, okay. Forget about the second mirror. First you look at the first concave mirror. My object is here, this is my object. This distance is 15 centimeter. 15 centimeter. Okay. The light goes towards left. What will be sign convention? This will be positive and this will be negative. Do you see? Okay. Focal length is 10 centimeter. So it is this focal length here. So this focal length of this will be 10 centimeter. Okay. Now, first image. First image. 1 over V1 is equal to 1 over F minus 1 over V. 1 over. What will be focal length? This is my sign convention. To the left is positive, right is negative. Focus of this mirror. Wherever is the center, focus is on the same side. Center is towards right because this is a part of a sphere. This is part of a sphere like this. Okay. Center will be towards right. Focus is also on the same side. Focus and center both are on the same side. Okay. For both mirrors. Okay. So it is going to be negative. I will write minus 10 here. Minus 10. Minus 1 over. This also is negative. Okay. It is minus 15. This will be 30. Here I will get minus 1 and this will become plus 2. Okay, what do I get? I get V1 is equal to minus 30 centimeter. Okay, so where is the image? Image is here at this point. This is my image. Okay, What it means is, if I draw the ray diagram, the diagram is going to look like this. Okay, if I take any light ray, after reflection, it is going to meet here. Okay. Similarly, one more light ray, this also is going to meet here, and they make one image. Okay. Now, these two light rays, these two reflected light rays, they meet at this point. Now, will they stop? After meeting, will they stop? Light rays never stop. They continue moving. Okay? And then I have a plane mirror here. This is my plane mirror. Okay? So if I do not have anything, okay, if I do not have anything, if I just have one mirror, then I get one image. This is my first and last image, final image. Okay. But if I have any other mirror, for example, in this case here, I have one mirror. At what distance? At a distance of 40 centimeter. 40 centimeter. Okay. This distance from here to here is 30 centimeter. 30 centimeter. Okay. My mirror is kept here. I have one mirror. This is my mirror. Now the light rays will continue. The light rays never stop. Okay. They continue moving, and then they will hit the mirror. They are going to hit the mirror. Okay. Now for this mirror, this mirror will think. What this mirror will think? This mirror will think that these light rays are coming from this point. So there is an object at that point. Okay. So this image becomes an object for second mirror. Image from first mirror becomes an object for the second mirror. It will make an image. Okay. It will reflect the light. The light will be reflected like this. Okay. This is how the light is going to be reflected. Okay. And if I trace them backward, so plane mirror will form an image. This is I2, I1. First image, second image. What will be distance? From the properties of mirror. Okay. What is this? This is 40 centimeter. That means this is 10 centimeter. 10 centimeter. This also will be 10 centimeter. This is where the second image will form. What will happen after that? Okay. These light rays, the light rays will continue moving. They will hit this mirror again. They are going to hit this mirror again. Okay. So now for this mirror, what this mirror will think? It will think that these two light rays are coming from this point here. So there is an object. Okay. So now this image becomes an object for this mirror. At what distance? 30 and 10, 40 and 10, 50 centimeter. Okay. So for this mirror, this becomes an object. It will again create an image. Okay. Such way, successive images, multiple images are formed. Okay. Since I have to just find the second image, so that's it. This is my second image. Okay. Now, what will happen if D is 30 centimeter? D is 30 centimeter. Second case, image forms at 30 centimeter. This is 30 centimeter. What will happen if I have a mirror right at that position? Right there, I have an image here. Okay. Exactly at same position, I have a plane mirror. And what will happen? Okay, what will happen? These light rays, this light ray, you see, these two angles are going to be same. Now, this light will be reflected, and this point here, the point here becomes an object for this. You can also say that I have a point object at the surface of mirror. At the surface of mirror. Object is at the surface of mirror. Image will also be at the same point, same position. Okay. So this will form a second image. A second image will be right here. Then these light rays will be reflected. This light ray will be reflected like this. Okay. So this becomes an object for concave mirror. This is first image. Second image is also at the same point. And third image will coincide here. This will become I3. I1 and I2. Both are at the same point. Okay. Then this I2 becomes object for this. Okay. So object is here, image is here. If I keep object here, image will be here. They will be interchanged. So the third image will form here. It will coincide with object. It will coincide with object. And that's what I have to find in this problem here. Here also, I have to find the distance separation between mirrors. I have to find this separation. This separation such that final image coincides with object. So I get first image from here, second from here. Okay. The final must coincide with this. The object. What should be that separation? So this is the meaning of coinciding. The image is formed here at the object, the site of object. That will happen if this distance is 30 centimeter. Now what will happen if it is 25? Now, this is very interesting. 25 centimeter. What will happen if I do not allow these light rays to meet? Okay, we are going to discuss this third case, that is 25 centimeter. Okay, and let me draw a bigger diagram. It's like this. I have this mirror. I have this mirror here. This here is my object. Okay, it is reflected. Okay, if I just have one mirror, that's it. I will get one image, that will be final image. I will get an image here. Okay. This distance is going to be 30 centimeter. This is 30 centimeter. Okay, what will happen if I do not allow the light rays to meet? Understand this. Okay, if I do not allow these light rays to meet here, what will happen? Essentially, that's the same thing that we are doing here. If the separation is 25, this separation is 25. That means this whole thing is 30. I am keeping a plane mirror here. I am keeping a plane mirror here. I do not allow these light rays to converge at this point here. I do not allow them to converge here. Okay? Then what will happen? What will happen? The light rays cannot come here. Okay. They just appear to be going towards this point, but they will not reach here. Now, for this mirror, this becomes an object. Try to understand very, very carefully. For this mirror, this becomes an object. Okay. If I did not have this, one image would have formed here at 30 centimeter. But I do not allow the light rays to converge here. Okay. In between, I am keeping this mirror. Okay. So from this mirror, light rays will be reflected like this. Light rays will be reflected. Okay. Like this. Okay. This becomes my second image. Second image. Okay. Now from the geometry, we know that these two distances are going to be same. If this distance is 5 centimeter, okay, because this is 30, this whole thing from here to here it is 25 centimeter, this is 5, this also is going to be 5 centimeter. Object distance is image distance. What type of object is this? This is known as a virtual object. A virtual object. What type of image is this? This is a real image. A real image from plane mirror. This is a real image from a plane mirror when I have a virtual object. Such type of objects are known as virtual. This point, they are acting like an object for this mirror. It is a virtual object. Okay, do you understand this? Okay. Now, okay, so we have to apply the same concepts in doing these problems. Okay, let's solve these two. Okay. Now, again here also, taking first reflection. So I'm going to get the same relation here also. Okay, I know where the image is going to be. Okay. Did you get the, okay, you should pause the video, get some answer, and then now we are going to discuss it. Okay. Where is the first image? First image. First image. Okay. V1 is going to be minus 30 centimeter. It is going to be minus 30. Okay. Do you understand this? Okay. The same. We have the same values. So I'm going to get the same answer. Okay. V1. That means my object is here. This is my object. This object is 2 centimeter. 2 centimeter. This distance is 15 centimeter. I'm going to get an image at 30 centimeter. What type of image? What will be magnification? You see, look at the sign convention. This is the sign convention. This is positive here and this is negative here. Okay, light rays are going towards left. That becomes positive. Right side becomes negative. For this mirror, understand it. This is for mirror M1. Forget about M2. We will bring it later. What is magnification? M1 from the first mirror, magnification, minus of V1 over V2. Minus of V1 over U1. U1 minus of minus 30 over minus 15, it becomes minus 2. Okay, height of image. Height of image. Which image? The first image. Height of first image is going to be equal to m times m1 times height of object is minus 2 times plus 2. This object is above the principal axis. Above the principal axis positive. Okay, this is going to be minus 4 centimeter. That means I am going to have an image here. This will be 4 centimeter. And what is this distance? This is going to be 30 centimeter. Okay, if I do not have any other mirror, I am going to get just one image. That's it, the last final image, first and last. Okay, but now I have one mirror here. Okay, so the light rays will converge here. They will make a real image, but the light rays never stop. They continue moving. Okay, and when they continue moving, they are going to encounter this mirror. I have this mirror here. This is 40 centimeter. Okay, so this is going to be 10 centimeter. Now this image, what is this? This is the image by M1. This image, which is this my object, this is my first image. This becomes an object for second mirror. Okay, an object for second mirror. Okay, so for second image, okay, what will be sign convention? Sign convention for this. Okay, so this is the object. Light rays are going towards right. Okay, so this becomes my sign convention. This is positive and this is negative. Each mirror will have its own sign convention. Look at the sign convention. It is down different. Okay, so for each mirror I have to separately decide the sign convention. Okay, now let's apply the formula. 1 over V2 is 1 over F minus 1 over U1. Okay, now for this mirror, focal length is positive. You see, this is a spherical mirror. Its center is going to be somewhere here, focus will be somewhere here. Okay, makes sense? Now, this focal length is 30 centimeter. This F is 15 centimeter. it is going to be equal to 1 over plus 15, focal length is plus 15 minus 1 over minus 10. Okay, makes sense? This is going to be equal to 30. This is plus 2 here, plus 2, then this becomes plus 3 here. Okay, so what is V2? It is going to be plus 6 centimeter. Okay, plus 6 centimeter, plus 6. Okay, so and what is magnification? What is magnification? M2 minus of V2 over U2. V2 over U2. Okay, this is going to be equal to minus of plus 6 over minus 10. Okay, so M2 is going to be equal to plus 0.6. Okay, this could be little confusing. What is height of second image? Height of second image. Okay, its height of second image is going to be equal to M2 times height of first image. Does that make sense? I am getting a positive magnification. This magnification is produced. It is produced by this mirror. It is positive. That means the object should be erect or inverted. It should be erect or positive. It is erect. 0.6. That means it is going to be diminished. Okay. Now this first image, it acts like an object for the second image. Okay, so this becomes an object for second image. This is going to be equal to plus 0.6 times, it is below the principal axis, it is minus 4. It is minus 2.4, okay, centimeter. It is going to be below the principal axis. Okay, this is my second image. It is going to be 2.4 centimeter. This is the second image. Okay, second image. From here, it says that the image is going to be erect, but now here I see that it is below the principal axis. Is there any discrepancy? Is there any discrepancy here? This says me that it is erect, but here I get it below the principal axis. That's why it is erect. What is the meaning of erect? Meaning of erect is the orientations are same for the object and image. If the object is downward, image will be downward. This is the meaning of erect image. Erect does not mean that image will be above the principal axis. Erect only means that orientation is going to be same. If object is below the principal axis, image is also below the principal axis. Okay? Now, understood? So that's fine. This is my final height. Now, one very important concept here. Very important concept. Okay? Let me discuss this. This is the height of second image. Okay. What was magnification? M1. It was minus 2. And what was M2? It was plus 0.6. What is this? This is magnification produced by the first mirror, magnification produced by the second mirror. Okay. Look at here. Height of second image is minus 2.4. Okay. Height of object is equal to plus 2 centimeter. Okay. What is magnification? Magnification is height of image over height of object. This is going to be equal to minus 2.4 over plus 2. It is going to be equal to minus 1.2. Minus 1.2. The final magnification, net magnification M is equal to minus 1.2. How do I know this? We actually calculated this. This is my object, 2 centimeter. Final image is here, 2.4 centimeter. It is inverted. That's how we find it. This is the final magnification, that is minus 1.2. Okay. Now, interesting thing. If I multiply both M1 and M2, this also is going to be minus 1.2. And here also I am getting the net magnification is minus 1.2. Is this a coincidence or it happens in all the cases? It happens in all the cases. In case of successive reflections, okay? In case of successive images, okay, net magnification M is equal to M1, M2 and all that. Successive, one after another. Okay, first magnification, first image, then second, then third, then fourth, one after another. Many images will be formed because of multiple successive reflections. In each step, some magnification is produced. M1, M2, M3, M4. There are magnifications produced in each successive step. The net magnification is going to be equal to the product of all of them. Okay, and this is something which is very, very important. You have to remember this, keep this thing in mind. Okay, will you remember it? Okay. Now the next one is little more interesting. Okay, the object has to the image has to coincide. Final image has to coincide. Reciprocity. Final image coincides with object. What does that mean? Final image is formed here. Light starts from here. It starts from here. It goes to the other one. Okay. And then the final should be here. Okay. It happens in two cases. I'm giving you this concept, this hint. Then you should try it yourself. It happens in two cases. Okay. Okay. The first case is that this itself forms an image here. It forms an image here. Try to understand. The problem is only apparently simple. Okay. There will be many layers. There will be many layers of this problem. Okay. Let's look at this. Okay. First, forget about M2. Let's focus on M1 only. All the values are given. This is 30 centimeter. This is 40 centimeter. So this focal length is going to be equal to 20 centimeter. Where will be image? Okay, do your calculation. The image is going to be equal to minus 60 centimeter. Okay. How do I know? I know this. I know if focal length is 20, object distance is 30, then this is going to be 60. Okay, I know I have done this. That's how I know this. Let me first draw the ray diagram. Let's say how it is going to look like. Okay, I'm going to do this big diagram. And this is my, okay, let's forget about the second. Let's focus only on the first one. Only on the first. Okay. This is my object here. Object here. Light rays start going towards the first. First image is considered from the concave mirror. Okay. And then they are they are meeting here. This is 60 centimeter. Object, this is my image. Okay. If I do not have this, that is the first and last image. That's it. Okay. Now, I have this mirror. What do I want? I want my final image to coincide with object. I want my final image to coincide with object. Okay. So the final image must be here. It must coincide. Under what conditions it will coincide? So this focal length is given. Under what conditions it will coincide? Okay, so try to understand this very, very carefully. Okay. First case is when this forms an image. Okay. Now, if this light ray falls on the second mirror here. Okay. Now, if this mirror forms an image here, or this is the first image. This is the first image. If it becomes, this is the first image. The first image becomes an object for the second mirror. Then this mirror will form an image here. Do you understand this? This will be a real image. A real image. A concave mirror, a convex mirror is forming a real image here. A real image. The object must be virtual. If the object is real, the image is always virtual from a convex mirror. But if the object is virtual, for example, this, I do not allow the light rays to converge here. Okay, in between they are intercepted by this convex mirror. Okay, then they cannot arrive here. They cannot arrive here. Do you understand this? Do you understand this? Okay, then this becomes a virtual object. This becomes a virtual object. The light rays will be reflected. They will be reflected and they will arrive here. Do you understand this? This whole distance from here to here is 60 centimeter. Okay. This distance is 30 centimeter. That means this distance is 30 centimeter. Okay. Do you see? Let's say that this is D. D I want to find out. Okay. Light rays are going towards right. Light rays are going towards right. Okay. So for this mirror, this will be the sign convention, positive and negative. Okay. Okay. From convex mirror. Convex mirror. Okay. So this becomes a virtual object for convex mirror. Image must be here. Image must be here. Okay. What will be U? U is minus B. Okay. No, this is no sir. No. This thing is U. This will be 30 minus B. Okay. U will be plus 30 minus D. It is plus. This sign convention sometimes causes confusion. In earlier classes, in junior classes, to simplify things, because they are junior classes, lower classes, just to simplify, almost everywhere it is written that you take object distance as negative. Object distance negative, object distance negative. Okay. It is given that way just because you are doing it for the first time in your lower junior classes. So that students do not get confused too much. Okay, so in an effort to simplify things, they say that take your object distance to be negative always. But that is not correct. Okay, now you have to come out of that thought process. We have a proper sign convention. The sign convention will dictate. The sign convention will tell me whether it is going to be positive or negative. The light rays are going towards right. So all the distances to the right of my pole will become positive. This is a virtual object. The object is kept behind the mirror. This is my object. This is acting like an object for me. It is behind the mirror. It's a virtual object. For this object, the object distance is going to be positive using sign convention. Image is formed here. Okay, it is going to be minus D. with sign convention. Focal length is going to be plus 10 centimeter. Plus 10 centimeter. Okay, now let's solve this. So 1 over B plus 1 over U is 1 over F. Okay. So let's write all these things. 1 over D plus, okay, minus 1 over D, 1 over B. 1 over 30 minus D is equal to 1 over plus 10 centimeter. Let's simplify this. This becomes D. So this becomes 30D. Okay, let me simplify this. 30D minus D square. Only, okay, just so that you don't get confused, let me write it like this. D times 30 minus D. This becomes minus 30 plus D. Minus is here. Okay, and plus D is going to be 1 over 10. Now let me simplify this. Minus 300. Okay, minus 300 plus 20D is going to be equal to 30D minus D square. Now you solve it, you get the answer. What I have is D square, okay, D square minus 10D minus 300 is equal to 0. Okay, this distance, I should get a positive answer. I am going to accept only the positive, not the negative. Okay, this D is equal to minus B. So 10 plus minus B square is 100. B square is 100 minus 4AC. So minus, so this becomes plus 1200. Okay, over 2. So 10 plus minus 10 root 13 over 2. I am going to accept only the positive answer, not the negative. Okay, so my answer is going to be equal to 5 plus 5 root 13. 5 plus 5 root 13. This is the answer. Okay, but this is only one of the answers. Okay, try to understand this. In this case, the final image is going to coincide here. But this is only one of the answers. We are going to get several answers for this problem. We are going to get at least 2 more. Okay, let's see how. This is one way of getting the final image coinciding with the object. Now there is one other way. Okay, I have this concave mirror. This is my object. This is the image. Okay. Now what will happen? What will happen if I reverse the image? Okay, the light rays are getting reflected. This is my incident ray. Incident ray. This is reflected ray. Okay. What if I reverse it? Because finally the light ray has to reach here. The light ray has to reach here. So if I simply reverse it, okay, if I simply reverse it, then everything will be reversed, and the light will finally reach at O. Light will start from O. It will finally reach at O. That means from somewhere it must retrace its path. Think about it. Think about it. Light ray starts from O. It has to finally reach the same point. That's how the final image will coincide with this object. That means the light ray must retrace. It must retrace its path. Now there are 2 ways of retracing it. In which case light rays retrace? When it falls normally. Okay, that means if I keep my convex mirror such that this light is incident normally here, and in which case it will be incident normally when this point, the point where they are going, if this becomes center of my mirror here, this distance should be equal to, this distance should be equal to 20 centimeter. If that happens, you see, this is my object. If I do not have this mirror, the image will form here. Okay. Now before the image is formed, I am intercepting these light rays by this mirror. Okay, do you see this? Do you see this? Okay. Now if these incident light rays, if they start to retrace from this point, then finally they will reach here at the starting point. That is the object. Okay. So I have to make these light rays retrace their path. They can retrace when they fall normally. And when do they fall normally? When they pass through the center. Okay, so these light rays must go towards the center of this mirror, M2. Radius is 20 centimeters. So this distance is 20. Okay, this whole thing is 60 centimeters. Okay, we calculated this. Then what will be this distance? This distance will be equal to 40 centimeters. So I have one more answer. 40 centimeters. Second answer. Okay, second answer is 40 centimeters. We are going to have one more answer. Now, can you think about it? Can you think about it? Okay. What will happen if I make some arrangement? Okay. What about this? Let me draw this again. This is my object. It forms an image here. Image I1. Now if I keep an object here, where will be image? Image will be here. Does that make sense? Object is at O, image is at I1. If I keep an object at I1, image will be at O. Okay? Reciprocity. That is reciprocity. How that will happen? What can I do? Okay, so I can keep my convex mirror right here, such that the image forms at the pole. The image forms at the pole of this mirror. Okay, in that case, these light rays will go like this. They will start from here, finally they will reach the object. Okay, that's how. Okay, so this is the image. Second image also forms here. Because the object is at pole. Image is at pole. Okay, then the third image will coincide here with the object. Okay, this distance is going to be equal to 60 centimeters. This is my third answer. We are going to have three answers for the same problem. 40, 60, and one other. That was 5 plus 5 root 13. Okay, now, does this answer make sense? What was this? This was D. I think we need to but this is not the answer. This was D. The answer will be 30, not 30. What is going to be the answer? 30 plus this, I guess. Answer should be 30 plus this. Okay? Are you getting confused? I think I am reporting this wrong answer here. We did it all right. But the answer I am reporting that is not fine, I guess. Okay? So this was my D. Okay? So this is what we consider as D. Okay? This was our first case. This distance was D. This is D. D we calculated to be this. 5 plus 5 root 13. We calculated. Then, but I have to find separation. So this separation, this will be equal to, this is 30 plus D. So my answer will be 30 plus 5, 35 plus 5 root 30. That will be my answer. I hope that you are able to make this correction. Okay. All right. Virtual objects. These are virtual objects. Okay. Now, one other important thing. Okay. So we discussed about mirror formula, image formation, ray diagrams, virtual object, okay, real object, virtual object, real image, virtual image, and all that. Let's move on to the new topic, that is speed of image. Speed of image. Okay. Now, before we derive any formula, okay, let's first try to understand this qualitatively. Qualitatively, okay. Be very careful. It's like this. It's like this. I am starting with a concave mirror. This is my concave mirror. Okay. Concave mirror. Okay. This is my focus. This is focus. This is pole. And this is center. Just to simplify, we are taking real objects only. Only the real objects. Okay. First case, U and V. Let's say that U is at infinity. I have an object which is at infinity. At infinity. Okay. Where will be image? At focus. Okay. Makes sense? This object is moving. It is moving towards the mirror. The object is moving towards the mirror. After some time, let's say that it starts approaching this center. It is here. Approaching the center. Now it is at a finite distance. Finite distance. We say it as beyond C. Beyond C. Beyond center. Now where will be image? From the property we know that the image is between F and C. F and C. This is the first situation. This is the first case. This is the second case. Third case at C. Image at C. This is the third case. Object here. Third case. Second case. First case. Let's compare this case. When object starts moving towards the center, when the object is at infinity, image is here. This is my image in the first case. Then image comes here. This is the second position of image. And this is the third position of image. Okay. So when the object is at infinity, image is at focus. As the object moves towards the mirror, the image is going away from the mirror. Okay. The image is going towards the center. Image is going towards the center. So this object is approaching the mirror. It is beyond center. It is at infinity. Okay. As it comes closer to, when it is at infinity, it is here. Okay? Understand this. When it moves towards the center, towards the mirror, it is center is here. The image is approaching in this direction. They are in opposite direction. At the center, both coincide. Now, when the object is between center and focus, okay, fourth case, between focus and center, then we have this image will be beyond center. Okay, this is reciprocity. Okay, this is reciprocity. Reciprocity. Okay, Understand this. Object beyond center, image between focus and center. Object between center and focus, image beyond center. Okay. Now, my object is moving between center and focus. It is approaching towards focus. Okay. Image is going in this direction. Okay. So, as the object moves, image also moves. We have to find a relation between object velocity and image velocity. Let's look at this case of convex mirror here. Convex mirror. Okay. When the object is at infinity, this is my object at infinity. This is the first position. Okay. Where is the image? Image will be at focus. This is the image. First position of image. Object at infinity. Now, as the object starts approaching towards the mirror, okay, the image shifts towards the pole. Object moves towards the mirror, image is also moving towards the mirror. Okay, and when object reaches the pole, image also reaches the pole. Okay, this is object second position, image will be somewhere here, second position. Object is approaching, image is also approaching, both are approaching. Even though they are moving in opposite direction, you see. Object was approaching the mirror. The velocity of image was to the left. Object velocity to the right, image velocity to the left. Object velocity to the right, image velocity was to the left. Think it in terms of approach and receding. Object was approaching the mirror. Image was receding away from the mirror. They had opposite velocity. Now here, they have opposite velocity. Object is moving towards right, image is moving towards left. They have opposite velocity. But think in terms of approaching and receding. Object is approaching the mirror, image is also approaching the mirror. Okay? So sometimes this question is asked, whether the image is approaching or receding away from the mirror. And it gets very confusing. Okay, if you do not understand this point well. Object and image both have opposite velocity in both cases. In one case here, object is approaching, image is receding. Here object is approaching and image is also approaching the mirror even though they have opposite velocities. Okay, now let's try to derive some relation. Okay. It's like this. Let's take one case of a concave mirror. This is pole, okay, this is focus, this is my center. Okay. Let's say that this is my object. Object is here. Okay. I'm going to get an image here. Okay. This is at time t. After a certain time, okay, object moves some distance in time t plus dt. T plus dt. Okay. The image will also move some distance. Now the rate at which their position changes, is changing, it will give me velocity of image and object. Okay. We can find it using this. 1 over v plus 1 over u is equal to 1 over f. Okay. Differentiate with respect to time. What I have is d over dt 1 over v plus d over dt 1 over u is d over dt 1 over f. Okay, differentiation. This becomes minus 1 over v square dv over dt. Okay, this also becomes minus 1 over u square du over dt is going to be 0. dv over dt, rate at which image distance is changing with time. Is it not velocity of image? It is. Okay. So this becomes minus 1 over v square into velocity of image minus 1 over u square, rate at which object distance is changing. It is object velocity. Okay. This is velocity of object. And I have this relation. Velocity of image is minus times v square over u square and velocity of object. Okay, it's pretty much clear. This whole thing is always going to be positive. Okay, that means velocity of image and velocity of object, they are in opposite direction. One is towards left, the other one is towards right. In terms of approach and receding, you have to be careful. Both may approach, both may recede from the mirror, and one may approach, the other may recede, depending on the mirror, and you have to be very careful. Otherwise, in terms of direction, they are always going to be opposite. Okay, let's do one question. An object, okay, moving with 5 meter per second, okay, approaches a concave mirror of radius 120 centimeter. Okay, at some instant the image formed, the image is erect and double the size of object. Okay, at some instant the image is erect and double the size of object. Okay, what is its velocity? What is its velocity? Okay, at that time, at that instant. Okay, what do you think? What is going to be? Pretty easy problem, not so difficult. Okay, Vi is equal to minus of V square over U square and velocity of object. Look at this expression carefully. Is this not something that we know already? V over U. What is this? Is this not magnification? It is nothing but magnification. Okay, I'm going to solve it already. You see, the moment I write a problem, you have to stop the video. Otherwise, I'm going to spoil all your fun. Okay, I am on rampage, you see. Yes, I am. Okay, image is erect and double the size of object. Image is erect, double the size of object. What means magnification? It is erect, so positive. Double the size, that means 2. That's it. This is the answer. This is magnification. So I have this answer. So minus of 2 square times 5 meter per second. That's it. Minus 20 meter per second. What is the meaning of minus? If object is moving towards right, image will move towards left. That is the meaning of minus. Okay. You will find many problems on this image velocity. Okay. Try answering all of them. Okay. Try to answer all of them. So this is about the velocity of image. Okay. So we are near the end of this topic, reflection. From the next lecture, we are going to start the next optical phenomena, that will be refraction, that is transmission. Okay. Let's conclude this with one last concept that is very important, and that is not something that you cannot do it already. I could have given it in problem sheet also, but I thought it otherwise, and then let me do it here. Okay. UV graph are pretty little difficult thing to do. Okay. And that difficult part I am leaving it to you. You try to figure out how UV graph for a mirror is going to look like. Okay. I am going to do the simpler thing. The simpler thing. The simpler thing will be 1 over V, 1 over U, 1 over U, and 1 over V. This will be simpler. Why? Because it is going to be a straight line. 1 over V is going to be 1 over F minus 1 over U. Okay. So if I take this as my y variable, and if I take this as my x-axis, okay, it is going to be a straight line. a straight line. Okay, you understand this? Understand this? Now, if it is a straight line, I just need 2 points to draw a straight line. I need just 2 points. If I know 2 points on the straight line, I know the straight line, the whole straight line. Okay, let's do it for a concave mirror. A concave mirror. A concave mirror. Okay, this is my axis. Okay, 1 over u and 1 over v. That's it. That's what I want. Okay. I know that the graph is going to be a straight line. I just need to find any 2 points. So let's take some standard points. Standard points. Okay. What are the standard points? Okay. U is minus infinity. What is going to be f? What is going to be v? V is going to be minus f naught. F naught is the magnitude of focal length. Magnitude of focal length. Okay. That means 1 by u is equal to 0. Okay. 1 by v is minus 1 over f naught. I'm going to get a point here. 1 by u is 0, 1 by v minus 1 by f naught. This is going to be minus of, this is going to be 0 minus 1 over f naught. 1 point. And then let's reverse it. That's it. That's how beautifully we do it. U is minus f naught. Okay. V is minus infinity. That means if u is minus 1 over f naught, v is 1 over v is going to be 0. 1 over u is minus 1 over f naught here. This is the second point, and that's all I need. Okay, this is going to be equal to minus 1 over f naught and 0. Join these 2 points, you get the answer. You get the answer. This is for a concave mirror. This is concave. This is for concave. We can do the same thing for a convex mirror. A convex mirror. Look at this. Object at minus infinity. This is my convex mirror. Look at the sign convention. Sign convention. Focal length is positive. This will be my sign convention for a convex mirror. The object is at infinity. Object is at infinity. This is my sign convention. Image is going to be at focus. Virtual image at focus. Plus f. So here I am going to get plus in. So 1 by u is 0. 1 by v is plus f naught. I'm getting a point here. This is 0 to plus 1 by f naught. Okay? And then reverse it. Simply reverse it. That's it. 1 by u is plus 1 by f naught here. This is 1 by f naught here. And then it is going to be 0. That's it. I got 2 points. I have this straight line. This is for a convex mirror. This is 1 by u and 1 by v. What about UV graph? That is going to be little difficult. Little tricky. You can do it. Of course, there is no doubt. You just have to reverse it. You just have to reverse these values. Okay. You are going to get the graph. Okay. It certainly is not a big deal. Okay. But then it is not required for your course. We are going to do it during discussions in the advanced course. Okay. If you are interested, you can do it, of course. That is going to be little involved. Next lecture we are going to start the next phenomena, that is refraction.